let's look at a confidence interval, focusing on how to decide what method to use and how to interpret GeoGebra's results. A Napa auto parts supplier wants to get information about the number of years car owners keep their cars. They obtained a random sample of 25 car owners, and this sample ended up having a mean of 7.01 years with a standard deviation of 3.74 years. We want to estimate the average number of years a car is owned out of all car owners using 90% confidence. So, the first question you should ask yourself to approach this and any statistics questions is, what kind of data do we have? Is it categorical or quantitative variable? And also, like, what are you being asked to do? In this case, what are you being asked to estimate? I find it helpful, in order to identify the variable type, to sometimes take a step back and identify what the individuals in the sample and what the variable of interest is in the sample. So, looking at this, it's on behalf of the auto parts supplier. They have a random sample of 25 car owners. So in this case, the individuals, the thing that they're studying, are people who own cars. And the thing that they want to know, like the thing that they measured from an individual owner, like if you think of every individual owner they went to, they asked them something, and what they measured was the number of years that they kept their car. So I'm going to say the variable interest in this case is the number of years the number of years that each one kept their car. So I will change the language just slightly. It doesn't matter that much, but just I want to be clear that it is not all car owners, but each individual car owner. We ask them, how long did you keep your car? So it's ultimately a number of years is the variable of interest. And then again, we want to be clear what we're trying to estimate in this case is the average number of years a car is owned out of all car owners. And just the thing that we want to focus on, remember, is that we're interested in trying to move from this sample of 25 to the whole sample of everyone. And we're specifically estimating like the mean of what that sample might be. Identifying these two questions then are going to help us move to the most interesting part. Let's do this calculation. Let's figure out the estimation. So this leads us to the estimation method. I skipped a slight part. I said we wanted to identify the individuals and the variable of interest to help us figure out what kind of data we have. So look at this, measuring the number of years that a car owner kept their car. That is a number, that is a measured quantity. If I took the difference between two, that value would make sense. So that means this is quantitative data. And that leads us to then, when I try and decide what method of estimation to use, we're going to want to be using quantitative methods. So let us move to our calculation. I'm going to go to geogebra.org/calculator, go to probability and select statistics. I am told that I'm doing an estimation, so I'm going to be living in this world of estimations. We only have one sample. We're just looking at car owners, so we don't want to do any of the difference questions. And in particular, we are trying to make an estimate of an average. We're estimating a mean. We have quantitative data. That means I want to be looking at means. To decide between z-estimate or t-estimate, for many classes, and if you were watching this and you were my student specifically, we will always be using T. Also, a good sign is we only have 25 car owners, so that means you should definitely be doing a T estimate of a mean. In general, if you have quantitative data, you should be using the T procedures, so T estimate. If you have categorical data is when you use Z. So we're going to do a T estimate of a mean because this is quantitative data. Then we need to identify our pieces of information. So the mean is the mean. Reading through here, it tells us that we have a mean of 7.01 years. So I'm going to type that in. I'm also going to record what I have just to help me. So the mean symbol is X bar, and again, the mean is 7.01 years. We got that just directly from the statement of the problem. The next question here is S. S stands for standard deviation. So we can see in here the standard deviation is 3.47 years. That's just read directly from the question. I'll type that in as well, 3.74. And then the last thing I need to identify is N. N is my sample size. And so, reading through the question, it tells me we've retained a random sample of 25 car owners. So, specifically that 25, that tells me my sample size is 25 in this case. So, I will type that in, and it gives me my calculation. What I want to focus on is the lower limit and the upper limit. Those two things there, that is what tells me my confidence interval. So if I enter it in just interval notation, I'm going to set two sets of parentheses, and it's just going to be these two values. Since this information is given in terms of 2 decimal places, I think I'm going to round it to like maybe even just 1 decimal place. Pay attention to instructions to decide what rounding you might do. So the lower limit is the 5.46, so rounding, that'll be about 5. Sorry, I pause here because I make this mistake almost every time. You should always remember to also make sure you actually enter in the confidence level. It's literally the top one here. It's asking for 90% confidence interval. So I should make sure that I set my confidence level to be 90. That changes my interval slightly. Still looking at the lower limit. So my lower limit here is 5.73 or so, and my upper limit is 8.289. So rounding, that would be 8.28. Sorry, 8.29, the thing that I am writing down here. Sorry for the delay. So this is the 90% confidence interval, but it's not so helpful in terms of actually interpreting what things mean. So remember, what we were trying to estimate was the average number of years a car is owned out of all car owners. So what this is saying is, I don't know exactly what the average car ownership is, but if I could like somehow ask every single car owner how many years they owned their car, they keep their car, and then find the average of that whole result, that average is going to fall somewhere inside of this interval with 90% confidence. So the way that you would interpret this sort of thing, we can make a sentence. The sentence could look something like this. We could say, we are 90% confident that the mean number of years all car owners keep their cars is somewhere between 5.7 and 8.3 years. So the thing to note with this interpretation that's important, you should always make sure that you specify somewhere in the sentence what your confidence level is. You want to make sure that you specify this is an estimation of a mean. It's not saying that like individual, so making a prediction about an individual person. It's not saying something about me personally. It's saying something about the average if we could add up everyone. And it's important to stress that this is all car owners, not just like the 25 in the sample. And then you should state your interval as well. A good rule of thumb when making your interpretation is kind of, you can say like, we are, insert confidence level here, confident that the insert mean or proportion, insert measure of variation in population, and then between whatever the two endpoints are. So you want to say like confidence level, be specific what you're estimating, be specific what the population is, like, so be specific what you estimated, and then state what the statement is. To apply this slightly, we could ask something like, say, is it, like, or we could, okay, so we don't know exactly where this interval is, but I could note that, say, it definitely shows that most people keep their car for longer than, say, 3 years. I have a friend who swears by getting a new car every 3 years, which seems crazy to me. And this definitely supports that slightly. That certainly, I don't know what the average number of cars are. We don't know exactly what the true average number of years of ownership for people is, but we can say that it's definitely above 3. So that can be useful. To summarize and cite then, to do a confidence interval, the first thing you need to identify is what kind of data you have. If you have quantitative data, then to do the estimation, what you want to use is the t-estimate of the mean. The S stands for standard deviation, N stands for the sample size. The thing you are interested in is the upper and lower limit, and you always want to finish your problem by putting it in context of the actual situation. Make sure you specify your level of confidence level, the measurement, and what the population is going to be. I hope you found this helpful.